In this question, we've been told that a discrete random variable x has negative binomial distribution with 6 successes required, each with probability of success 0.4. We're first asked to determine the expectation of x. As always, let's actually define the distribution. Let's write it down. X follows a negative binomial, r is 6, p is 0.4. The expectation, well, that's r over p. R is our 6 and p is our 0.4, and that gets us 15. The expected number of attempts before we completed our set of 6 successes is 15. 15 attempts to achieve 6 successes. Next, we're asked to find the variance of x. The variance can be found using the formula RQ over p squared. Q is 1 minus p. That's going to give us 0.6. 6 times 0.6 over 0.4 squared. And that gives us an answer of 9. In part C, we're asked to find the probability that x equals 12. Well, that's the probability that it's going to take 12 attempts for us to get our 6 successes. As always, for the negative binomial, we set out this diagram to frame our thinking. We know the very last attempt needs to be a success. So, one of the 12 attempts is accounted for. In the first 11 attempts, anything can happen in any order, but we know we must achieve 5 successes in those first 11 attempts. So we're just going to process these two things, focusing on this highlighted portion. We know that this highlighted part is just going to be a binomial distribution probability. So if n equals 11 and we're looking for 5 successes, we can do 11c5, probability to the power of 5, failure to the power of 6. And then we'll multiply it by the final success we know happens in the last slot. Okay, that's 11c5, p to the 6, q to the 6. The probability that x equals 12 we can find by substituting our value for p, that's 0.4, and substituting a value for q, which will be 0.6. And that gets us an answer of 0.08829.